Assalamualaikum and hi everyone, this is Dr. Shazira. So in this video we are going to be solving one example of heat equation using Crank Nicolson scheme. Consider this problem where you are given the heat equation in this form with the boundary conditions, two conditions here. The left boundary condition is u0 t equal to 0, and at your right boundary the value of u is also 0, and you have one initial condition here, u at 0 equals sine 2 pi x. All right, so find the solution ux 0.01, okay, using Crank Nicolson scheme with h equals 0.1 and k is 0.01. All right, so we start our working process with sketching the grid of solution. All right, so on the x-axis we need to start with the x naught. Okay, so this point here is your x naught. So x naught is 0. Okay, so you have your x from 0 to 0.5 here, and then the increment of x is 0.1. So x naught equal to 0, and then somewhere here you have your x1 is 0.1. Okay, because the increment is 0.1. And we have x2 is 0.2, x3 is 0.3, x4 is 0.4, and lastly you have x5 is 0.5. Okay, so you must stop at x5 at 0.5 because this is what has been given by the interval of x, okay, in your problem here. That is for the x-axis. For the y-axis, or correspond to the tj here, so we start with t naught, so equal to 0, and the increment of t is k, where k is 0.01. So here we have t1 equals 0.01. So we can stop over there because the problem asks you to find the solution up to t equals 0.01 only. If the question asks you to find the solution for ux comma 0.02, for example, then you need to have one more t here, t2 equals 0.02. But for this case, only one level. So next, we need to form the rectangle, all right, so that we know our grid of solutions looks like. Okay, so at each intersection point between the horizontal and vertical line, so basically denote our u. So somewhere here is our u with the notation of u00. Okay, so basically you look at the subscript of x and t. So in short, we write u00. Basically the value of u when x is x naught and t is t naught. Okay, so this point at your right here is u10. Okay, you are still at t naught, but your x is changing. So u10, and this is u20, u30, u40, u50. And at the top here, we have u01. Okay, because the level of t now is t1, subscript is 1, so u01, and this is u11, u21, u31, u41, and lastly we have u51. Okay, so that is our first step to be able to sketch the grid of solution, okay, so that we can see clearly the u with the correct subscript that involved in our calculation. So step number 2 is to consider the given boundary conditions, and we want to find the initial solutions based on the boundary and initial condition. All right, so your first boundary condition is u0t here. So u0t equal to 0 for t is greater or equal to 0. Okay, so the first one, so we write down here u0t equal to 0 for t is greater or equal to 0. Okay, and now based on our grid, we need to identify where or what are the nodes, okay, that involve for this boundary condition here. u0t equal to 0 simply means the value of u is 0 when x is 0 and regardless the t. okay, regardless the value of t. So the corresponding nodes, okay, that involved based on this boundary condition is u00, because this is where x equal to 0, and this is also where x equal to 0. Okay, so we can write straight away u00 equal to 0 and u01 equal to 0. So it simply means, okay, we know the value of u00, we also know the value of u01, which is 0. Okay, and then you also have the condition u 0.5t, which is also equal to 0, and t is greater and equal to 0. So again, we need to find the nodes where x value is 0.5. Okay, so based on the grid, this is where x is 0.5, x5 equals 0.5. Okay, so we have two nodes, u50 and u51. So now we can straight away write u50 equal to 0 and u51 equal to 0, because this boundary condition says as long as you are at x equals to 0.5, so we don't care about the value of t, so you can put straight away the value of u is 0. Okay, so by those two boundary conditions, so basically we know the left and the right boundary values. Okay, and then we have the initial condition. So your initial condition is u x0 equals sine 2 pi x. Okay, now where are the nodes, or what are the nodes that involve based on this initial condition? So it says that as long as you are at t equal to 0, okay, your value of u depends on where you are, depends on at what value of x. Okay, so t equal to 0. T equal to 0 is basically u00, but we already have u00 somewhere here. But in fact, if you uh, put the value sine 2 pi, x is 0 here, so you will also have 0. So u00 somehow here tally with this value based on the boundary condition. Okay, so we have u10, okay, u20, u30, u40, and u50. But somehow u50 is already 0 here. Okay, so notes that involve u10. Okay, so what is the value of u10? It is sine 2 pi x. X at that location, u10 is 0.1. So you calculate sine 2 pi 0.1, which will gives you 0.5878. And similarly for u20, so we have sine 2 pi. Now x is 0.2. Okay, so we have 0.9511. Okay, so with the same justification or the same process, so u30 is basically sine 2 pi times 0.3, so you will get 0.9511 as well, same as 0.20. And finally you have u40, which is sine 2 pi times 0.4, which will gives you 0.5878. Okay, so it means that by that initial condition, so basically we know u10, u20, u30, u40. Okay, so if you imagine you have this domain based on the boundary and initial condition, so you are basically know the value at your left boundary, your value of u at the right boundary, as well as at the bottom part. Okay, and so what's left now that you need to get? So you need to find u11, u21, u31, u41. So there are four nodes which considered your unknowns here, okay, that need to be determined at the end of the process. Okay, that is step number 2. Now look at the step number 3. Write the PDE, or the heat equation in this case, in a finite difference form. Okay, so our our heat equation given in the problem is u sub t, or del u del t, equals 0.5 uxx. Okay, so before this, in the previous previous discussion, we have seen the formula, okay, that we need to use in u sub t and uxx. Okay, if I can show slightly here. So this is what we have before. For the u sub t, we need to use the centered difference formula, but we evaluate at tj plus half. So we end up with this finite difference formula. And for the uxx, okay, so we end up with this, okay, expression here. Okay, so now let's replace the u sub t and uxx, okay, based on our previous discussion on the Crank Nicolson scheme. All right, so u sub t is uij plus 1 minus uij over k. Okay, that's u sub t equals 0.5 at the right, and then here we have uxx, which is 1 over 2. Okay, and then we put ui minus 1, okay, j plus 1 minus 2 uij plus um, sorry, here j plus 1, j plus 1, and then we have plus ui plus 1 j plus 1 over h square. Okay, that is uxx, but you evaluate at j plus 1. Okay, plus with the uxx, but you evaluate at level j. Okay, so ui minus 1j minus 2 uij here plus ui plus 1j over h square. Okay, so what we can simplify now, okay, because we know our h and k, okay, and then we can simplify further. Okay, so we know that our h is 0.1, k is somehow 0.01. Okay, so now what do we have? So again, the idea is to write down all terms, okay, that involve j plus 1, level j plus 1, to be at the left side, and terms that involve with the j, okay, you put on the right hand side. Okay, then we have this kind of expression. All right, so we have this expression. So try to rearrange your terms. Okay, again, the rules is to put j plus 1, terms with j plus 1 to be at the left side, and terms with the j only you put at the right hand side. Okay, but for each of the side here, so try to write or arrange your u term according to the position of the grid. So it means we put ui minus 1 first. Okay, so in the middle should be ui, then on your right should be I plus 1. Okay, so you can imagine the grid, I in the middle, so the left is I minus 1 and the right is I plus 1. So the same thing at your right hand side, all of them are level j, but in terms of I, okay, so we put I minus 1 first, so in the middle is I and at the right is I plus 1. All right, so this is your heat equation in terms of Crank Nicolson scheme. Okay, in terms of finite difference form with a Crank Nicolson scheme. Okay, so this equation can be summarized in terms of molecule diagram, as you can see earlier in the previous discussion of Crank Nicolson scheme. All right, so in terms of molecule diagram, so we have okay, so at the top we have 3 nodes. Okay, this one correspond to your left expression, and at your right you also have 3 terms of u. Okay, if I can put like that. So look at your left hand side. So this is ui minus 1 j plus 1, and this is ui j plus 1, and this is ui plus 1 j. Okay, so it need to be correct accordingly. So ij plus 1, okay, in the middle. I minus 1 should be on the left, I plus 1 should be on the right. Okay, and then at your right hand side, so you have u I minus 1j. Okay, so the level is j, so it should be below j plus 1, not higher than j plus 1. So this is uij, and this is ui plus 1j. Okay, so the coefficient here is negative 0.5, so this is 3, this is negative 0.5. Okay, so the relation is, so three nodes at the left, which correspond to the upper part of this molecule diagram, is equal to, okay, 0.5 times ui minus 1, or I can put at the bottom. So 0.5 here, the coefficient of ui minus 1j, and this is 1, and this is also 0.5. Okay, so that is your what we call the computational molecule, or molecule diagram, okay, which correspond to your equation over here. All right, so now again you must remark this uij plus 1 here to be what we call the reference node or the targeted cell. Okay, so your reference node or the targeted cell. All right, so that is the third step. Okay, so now fourth step, form a system of linear equation. Okay, so our aim is to know these four nodes here. Okay, based on our grid just now, we have seen that the unknowns are these four nodes. Okay, so somehow we will end up with a system of linear equation, because we can see from this expression, in order for you to get u11, for example, okay, so it is also involved with the left and right node somehow. Okay, so this is different from the explicit scheme. So in the explicit scheme, you have this kind of molecule diagram where this is what you want to get. So it corresponds to only three nodes at the bottom, which you have the value. But somehow, in order for you to get this guy here, somehow you also need to consider the left node and the right node, which is also unknown. Okay, so we cannot have the value of u11 in a straight away manner, so we somehow end up with a system of linear equations, and then after that, we will solve the linear system to get the value of our unknowns. All right, but what we are going to do here is to look at the first aim is u11. Okay, and we need to map this u11 to our reference node, which is uij plus 1. Okay, so by looking at those two, then we know that the first value of I should be 1, j should be 0. Then we somehow come up with u11. Okay, so but with that I and j, so we are going to have, the value of u somehow is u01. Okay, u01 here, this is u11, and this is u21. Okay, so again, by our molecule diagram, so when I equals 1, j equal to 0, so see what happened now. We end up with negative 0.5 u01. Okay, I minus 1, j plus 1, so u01 plus 3 u11, okay, minus 0.5 u21. Okay, that is on your top molecule here, which correspond to the left expression of this equation here. Okay, so that one is equal to, okay, so at the bottom here you have 0.5, so 0.5 u, now it becomes 0, 0, plus 1 u10 uij, and then plus with a 0.5 u20. Okay, so now once you come up with this expression, check, Okay, what are the nodes that you have the value? Okay, for example, we know the value of u01. Okay, so you need to go to step number 2 and check what is the available nodes. Okay, the available value of the nodes that you can see in this expression here. So the u01 is basically known, u00 basically known, u10, u20 are basically known. Okay, so plug in the value accordingly, and then the known value that you can see here, you need to put on the right hand side, because our intention here is to form a linear system. So the unknowns should be at the left hand side, the known value should be at the right hand side. Okay, so somehow you should come up with 3u11 minus 0.5 u21. Somehow the simplified value is 1.0634. So I hope you can work out on that and get the same answer as mine. Okay, so that is first equation. So we denote this one as 1. Okay, so we have 4 unknowns here. So basically we should form 4 equations, okay, for us to be able to form or to solve the linear system, and at the end get these 4 unknowns. All right, so now the second equation will be formed based on our next aim is basically u21. Okay, so again you look at u21 and you refer to the reference node here. Okay, then you can identify what is the correct I and J that you need to use in order for you to come up with U21. So in this case, I should be 2, J still 0. Okay, so all right, I equals 2 now, J still equal to 0. So based on, basically you can look at the expression at the top here, okay, at the first, for the first equation. So negative 0.5, so you are changing in terms of I, J remains, so you only raise 1 unit for the I. So it becomes U11, okay, plus 3 U21 minus 0.5 U 3, 1 equals 0.5 u10 plus u20 plus 0.5 u30. Okay, so again, look at your step number 2. This is basically known, u20 also known, u30 also known, but on your left hand side, all of the u's basically your unknown. Okay, so you just leave it there at the left hand side. So you will end up with now the same here, because they are basically still unknown at the moment. But at the right hand side, the simplified value should be 1.7206. Okay, next, okay, so put this one as equation 2. Next is to look at your third aim, which is u31. Again, okay, you map to this reference node, then you know I should be 3, J should be 0 for you to produce u31. Okay, so again, I equals 3, J equal to 0. So now you have negative 0.5 U21 plus 3 U31 minus 0.5 U41. Okay, equals 0.5 U20 plus U30 plus 0.5 U40. So what do we have? What do we know? U20 is known, U30 as well as U40. Okay, so simplify the right hand side value, we should end up with negative 0.5 U21 plus 3 U31 minus 0.5 U41 equals 1.7206 as well. Okay, the same as in equation 2. So put this one as equation 3. And lastly, look for U41, okay, and map to the reference node, then we know I should be 4, J should be 0, okay. So I equals 4, j equal to 0. So see, we end up with negative 0.5 u31 plus 3 u41 minus 0.5 u51 equals 0.5 u30 plus u40 plus 0.5 u50. Okay, so again, look, u30 is known, 40 also known, 50 also known. At the left hand side, okay, so you can see your 3 u31 is basically your unknown here. 31 unknown, 41 is unknown, 51 somehow is not your unknown. So basically there should be a known value for u51. So go back to your step number 2 and see the value of u51 is also basically known. Okay, so you put the value of u51 and bring to the right hand side together with the remaining values, yeah, at the right hand side, and simplify, okay, and then here you have negative 0.5 u31 plus 3 times u41, and then at the right hand side it should be 1.0634. Okay, so put this one as equation 4. So where are the linear system then? Okay, so based on equation 1 to 4. Okay, so see, the unknowns that you have is basically these 4. Okay, so we need to you can write in terms of matrix. Okay, so in terms of matrix, if you take out your unknown, start with u11 just now, and then you have u21, and then you go to u31 and u41. Okay, so the coefficient, okay, maybe you can put at the right hand side first. From the first equation, the right hand side value is 1.0634, and then you have 1.7206, 1.7206, and equation 4, 1.0634. Okay, and look at the coefficient. Okay, based on equation 1, you have 3u11 minus 0.5. So 3 and 0.5. 3, 0.5, and you don't have u31, you don't have u41, so basically 0 and 0. And then based on equation number 2, you have negative 0.5, so look at your equation number 2, and then 3, negative 0.5, and this is 0. Equation number 3, you don't have u11, so 0, and then you have negative 0.5, 3, and negative 0.5. Okay, and lastly, equation number 4, you don't have u11, you don't have u21, but you do have u31, so the coefficient is negative 0.5, and finally u41 with the coefficient of 3. So this is our linear system. So finally, step number 5, solve the system. Okay, solve the system simply means obtain your unknowns. Okay, solve the system. So in the exam, look carefully. If the question asks you to do a specific method to solve the system, then just follow. Okay. But this one basically 4 by 4 system of 4 by 4. So if the question didn't ask for any specific method, you can simply use your calculator to get the unknowns u11, u21, u31, and u41 here. Okay. But if the question asks for the Thomas algorithm, for example, or a Gauss-Seidel, so you need to follow. Okay, so but for now I just put here by calculator. So by calculator, your u11 is 0.4854, u21 is 0.7853, u31 equals 0.7853, and u41 equals 0.4854. Okay, so that's it. So that's how you solve the heat equation using the Crank Nicolson scheme.